Hi dear students, I welcome you to this new video, and this video is about various axioms for the real numbers and integer. So I'm going to discuss some of the axioms in mathematics that are used for real numbers and the integers. Uh, we assume that the following statements are true. The first axiom is that of existence. There exists a set R which consists of all real numbers, and it contains a subset Z, that is Z is a super subset of proper subset of R which consists of all integers, and that is true. The set of all integers is a proper subset of the real number set R. The closure of Z, if A and B are integers, then so are A plus B and A times B. Closure of the R, the real set, if A and B are any real numbers, then so are the A plus B and AB. Continuity or commutativity. A plus B is equal to B plus A, and AB is equal to B times A. So the commutative property means that A plus B is equal to B plus A, and AB is equal to BA for all real numbers A and B. Associativity. Associativity means that A plus B plus C is equal to A plus B plus C, and AB times C is equal to A times BC for all real numbers A, B and C. Then we have distributivity, and distributivity means A times B plus C is equal to AB plus AC, and A plus B times C is equal to AC plus BC for all real numbers A, B and C. 0. 0 is an integer that satisfies A plus 0 is equal to A is equal to 0 plus A for every real number A. 1. 1 is an integer that is not equal to 0 and satisfy that A times 1 is equal to A is equal to 1 time A for every real number A. We also have additive inverse. If A is any real number, there is a unique real number minus A such that A plus minus A is equal to 0. If A is an integer, then so is minus A. Multiplicative inverses. If A is any non-real number, there is a unique real number A raised to the power minus 1 such that A times A inverse is equal to 1. Trichotomila. If A and B are real numbers, then one and only one of the following three statements is true. A will be less than 0, or A will be equal to 0, A will be less than B, or A will be equal to B, or A will be greater than B. Closure of R plus. If A and B are positive real numbers, then so are A plus B and AB. Addition law for inequalities. If A and B and C are real numbers, then and A is less than B, then A plus C is less than B plus C. Similarly, we have the well ordering axiom. Every non-empty set of positive integers contains a smallest integer. I'll discuss some selected theorems, and we will start with the properties of 0. A minus A is equal to 0. 0 minus A is equal to minus A. 0 times A is equal to 0. If AB is equal to 0, then either A is equal to 0 or B is equal to 0. Properties of science. Minus 0 is equal to 0. Minus into minus A is equal to A. Minus A times B is equal to minus AB, or A into minus B. Minus A into minus B is equal to AB. minus a is equal to minus 1 times a. We have some more distributive properties. Minus a plus b is equal to minus a plus minus b, and that is equal to minus a minus b. Minus a minus into a minus b is equal to b minus a. Minus into minus a minus b is equal to a plus b. A plus b is equal to 2a, and a times b minus c is equal to ab minus ac, and that is equal to b minus c times a. A plus b into c plus d is equal to ac plus ad plus bc plus bd. A plus b into a plus b into c minus d is equal to ac minus ad plus bc minus bd, and that is equal to c minus d times uh, a plus b. A minus b into c minus d is equal to ac minus ad plus bd minus bc. Properties of inverses. If a is non-zero, then so is a raised to the power minus 1, or the inverse of a. A, sorry, 1 raised to the power minus 1, that is the reciprocal of 1, is equal to 1. A raised to the power minus 1 whole raised to the power minus 1 is equal to a if a is non-zero. Minus a raised to the power minus 1 is equal to minus a raised to the power minus 1 if a is non-zero. AB raised to the power minus 1 is equal to a raised to the power minus 1, b raised to the power minus 1 if a and b are non-zero. That is, AB, the reciprocal of AB, or the inverse of AB, is equal to a inverse, the inverse of a, and the inverse of b. A divided by b raised to the power minus 1 is equal to b over a if a and b are non-zero. Properties of quotients. A divided by 1 is equal to a. 1 divided by a is equal to a inverse, or the reciprocal of a if a is non-zero. A divided by a is equal to 1 if a is non-zero. A divided by b times c divided by d is equal to ac divided by bd if b and d are non-zero. A divided by b whole divided by c divided by d is equal to ad divided by bc if bc and a are if bc and d are non-zero. AC divided by bc is equal to ab if b and c are non-zero. Similarly, a times b divided by c is equal to ab divided by c if c is non-zero. ab divided by b is equal to b if b is non-zero. Minus a divided by b is equal to minus a divided by b, and a, that is equal to a divided by minus b if b is non-zero. Similarly, minus a divided by minus b is equal to a divided by b if b is non-zero. A divided by b plus c divided by d is equal to ad plus bc whole divided by bd if b and d are non-zero. A divided by b minus c divided by d is equal to ad minus bc whole divided by bd if b and d are non-zero. Now we will discuss some transitivity of inequalities. If a is less than b and b is less than c, then a is less than c. If a is less than or equal to b and b is less than c, then a is automatically less than c. If a is less than b and b is less than or equal to c, then a is less than c. If a is less than or equal to b and b is less than or equal to c, then a is less than or equal to c. Other properties of inequalities. If a is less than or equal to b and b is less than or equal to a, then a is equal to b. If a is less than b, then minus a is greater than minus b. 0 is less than 1. If a is greater than 0, then the inverse of a is greater than 0. If a is less than 0, then the inverse of a is less than 0. If a is less than b and a and b are both positive, then uh, the inverse of a is greater than the inverse of b. That is, a raised to the power minus 1 is greater than b raised to the power minus 1. If a is less than b and c is less than d, then a plus c is less than b plus d. If a is less than or equal to b and c is less than d, then a plus b is less than b plus d. If a is less than or equal to b and c is less than or equal to d, then a plus c is less than or equal to b plus d. If a is less than b and c is greater than 0, then ac is less than bc. If a is less than b and c is less than 0, then ac is greater than bc. If a is less than or equal to b and c is greater than 0, then ac is less than or equal to bc. If a is less than or equal to b and c is less than 0, then ac is greater than or equal to bc. If a is less than b and c is less than d and a, b, c, d are non-negative numbers, then ac is less than bd. If a is less than or equal to b and c is less than or equal to d and a, b, c, d are non-negative, then ac is less than or equal to bd. If ab is greater than 0, ab is greater than 0, that is, it is positive if and only if a and b are both positive or both negative. ab is less than 0 if and only if one is positive and the other is negative. There is no smallest positive real number. Density. If a and b are two distinct real numbers, then there are infinitely many rational numbers and infinitely many irrational numbers between a and b. Thanks for watching. These are the various theorems about real numbers and integers, and I hope these were quite informative and useful for you. You may use that in your own analysis in mathematics